All right, so now we can continue on with perpendicular lines. And before we begin, a calculator is needed for this lesson, so please make sure you have a calculator available to start this lesson, and you're going to want to copy down the distance formula. All right, so let's get started. It says finding the distance from a point to a line. So when we want to find the distance from a point to a line, we want to find the shortest distance. So what that looks like is when we are given a point to start off with, we want to travel to the shortest distance. And the dead giveaway is actually that right angle box. So again, following the shortest distance. We're going to calculate that distance using coordinates. So in the very first example, it says find the distance from point A to line BD. Now I'm going to highlight line BD. And there is line BD. Now you can see on line BD, there are 3 points on line BD. We have B, C, and D. The shortest distance to travel on this line so happens to go from A to C. It's not because it's in the middle. It is because it's the line that has that right angle. So I'm going to calculate that distance, which I already wrote point A, -3, 3, to point C, 1, -1. For my distance formula, I like to stack my ordered pairs. So that way I have my x's together and my y's together. So here are my x's and here are my y's. And I'm going to put that right into my distance formula. So here you can see I start my distance formula with my square root symbol or my radical symbol, and then my parentheses. So I have -3 minus, comes from our equation, 1 squared plus 3 minus -1 squared. And I'm going to take this piece by piece. I don't plug it into the calculator until the very end. All right, so in this parentheses, I have -4 squared. In this parentheses, I have +4 squared. Remember, the two negatives, when they touch, creates a positive. So here, when we square, remember that when we square a negative, it will be positive. So I have 16 plus 16. So I have the square root of 32, which is approximately, and that squiggles means approximately, 5.7 units. So that would be my final answer. All right, so I would like you to try the next one on your own. You're starting from point E, traveling to one of the points, which would be the shortest distance. So identify the shortest distance and then calculate it. All right, so let's go over it. So here we're going to travel to, and I'll highlight it as well, to G. So you should have picked G. All right, so G is 0.12. And setting up my distance formula, we have -4 minus 1 squared plus -3 minus 2 squared. I want to clean that up. So we have -5 squared plus -5 squared. It doesn't always end up being the same numbers in those parentheses, so be mindful of that. It just happened for these two problems. All right, so we have the square root of 25 plus 25, which is the square root of 50. Take that square root in our calculator, and we have 7.1 units. In your basic calculator here, to get that square root, if you're not sure, you're going to press that second button, so make sure it's on. So here I would press second and x squared to get that square root symbol, and 50. And that's how I'm getting my 7.1. I'm rounding to the nearest tenth. So again, that second and x squared button gives me my radical button. All right, a little more vocabulary. It says here, line that we have a perpendicular bisector. We've already heard the word perpendicular. We've already heard the term bisector. Now we're putting them together. So in this diagram, they're saying N, line N is that perpendicular bisector. So it does something to my picture. So what it does is the first thing, it creates a right angle. So perpendicular creates right angle. And then the word bisector, as we already know, we have our two congruent tick marks. So it splits into two congruent parts. Right, so be mindful that those words actually do something. So every time we hear the term perpendicular, we know we're creating a right angle. When we hear the term bisector, we're splitting in half. And now when we put the words together, it does both of those things at the same time. All right, so here we have some theorems or rules that we're going to apply. All right, so it says linear pair perpendicular theorem. So breaking apart what we know. So linear pair, we already know that that equals 180 and is adjacent. Perpendicular, we know that that means 90 degrees. So in our diagram, it says that here we have these two angles. And it says if angle 1 is congruent to angle 2, and angle 1 plus angle 2 equals 180, what would angle 1 and angle 2 have to be? They would have to be 90 degrees. So that means I could actually draw those right angles on my box and say then, if they're both 90 and 90, then G is perpendicular to H. So do not forget our symbol for perpendicular is that upside down T. All right, next rule that we might already know. So here it says perpendicular transversal theorem. We've looked at transversals before. So what this is saying, it's saying is if H is parallel to K, so H is parallel to K, and J is perpendicular to H, then J is perpendicular to K. So what does that mean? That means if we have a right angle here between J and H, well, then we need to have that right angle for J and K when our two lines are parallel. Remember, that would be our transversal, making those two angles corresponding. So I'm just dropping it down. All right, then we have lines perpendicular to a transversal theorem. So here we have, I'm going to write in different colors for this one. Here we have M is perpendicular to P. Now, how do I know that? Because M and P create that box. And then I can say that N is perpendicular to P. They create that box. So I hope you can see that we both have P in common, meaning that they created those right angles, which is really a transversal that's hidden, which means that we have parallel lines. And which lines are parallel would be M and N. All right, so we're going to take that knowledge and apply it to some practice problems that I'm going to do with you together and then try some on your own. All right, so I'm going to jump to number 3. So number 3, we want to find the distance from A to BC. So here we have A, and here is BC. I'm going to highlight BC. So A is -3, -3. And which point am I going to go to? B, D, or C? Which one is the shortest distance that has the right angle? And in this case, it's that side piece right here. We're going from A to C. Notice it's not in the middle. Doesn't always have to be in the middle. So 1 to -1. So we're going to create our distance formula. So I'm actually going to do this on my post-it right here. So here we have -3 minus 1 squared, -3 minus -1 squared. Be careful on your negatives. Take it step by step. So here then we have -4 squared. And now this one we have to be careful with. So this would become a plus sign. So it's -3 plus 1, which would be -2 squared. Now we're going to simplify. -4 squared is 16. -2 squared is 4. Square root of 20, which is approximately 4.5 units. All right, so I would like you to try questions 2 and 4. So you could pause your screen, and then I'll show my work. All right, so for number 2, you should have went from A to D. And your answer should be approximately 8.5 units. Does rounding matter? Yes, it does. Make sure you're following the rules of rounding based on the directions or whatever directions your teacher is telling you. So in this case, I'm rounding to the tenths. All right, number 4, we're going from A to C. And here you should have 2.2 units. You should make sure that your answer is reasonable to about the boxes that you're traveling. So that should be a nice, easy comparison. All right, so let's look at some questions at the bottom. It says, determine which lines, if any, must be parallel. All right, so we're going to start with number 7. I'm going to use my knowledge of perpendicular to be able to figure out which ones are parallel. All right, so here we have my first right angle. Which two make that right angle? So that would be M and J. Okay, what makes my next right angle? So let's go with this one. That would be N and K. And then my last one would be M and K. So what we're trying to do is to see which ones can connect, just like we did in the previous problem when they share a letter. So I can see that these two share K right away. I can see that they share K. So how would I write that? I would say, since they share K, I would say N is parallel to M. But I also have M over here and M over here. So line J and K share line M. So that means I can say that J is parallel to K. All right, I would like you to try number 6, and I'll show you my answer. All right, so in number 6, I could see that these two are perpendicular with that right angle. So what are they? They are R is perpendicular to P, and this one is R is perpendicular to Q. So what would that give me? So you can see we have R in common. So I could say P is perpendicular to Q. All right, so now number 8 is a little bit more work, and we're going to do that one together. So there's a little bit going on. So the first thing I want to identify is angle 1 and angle 2. So angle 1 and angle 2 are congruent. So we can see that they are a linear pair. And congruent, which means angle 1 equals 90 and angle 2 equals 90. So I'm going to actually change this to right angles. All right, so now I'm going to write all my pairs that create right angles. So I have my first one here, N is perpendicular to S. I have N is perpendicular to T. And then the last one over here is M perpendicular to S. Notice I didn't color in angle 1 because that is a duplicate of still giving me N and S. So I don't need to write that a second time. So now based on this, what lines are parallel? So I see that I have two N's, so that would create S is parallel to T. I could also see that I have a duplication of S and S, which means I'm going to have N is parallel to M. And that's all I have in that example. All right, so we're done with this lesson and we're going to try more practice in class.